Hello and welcome to another video, and it's time to do the next part of the humanoid robot project, a project that should nicely complement the suit of powered armour. And as you might have guessed from the thumbnail, it's time to do the forearm of the project, which should nicely attach onto the hand from the previous video. It is worth noting all of this is a Mark 1 variant, if you will, and it's all really to test the simplest way of actuation for all of the fingers and all of the movement in the wrist. So a big part of this video is actually going to be testing the different thicknesses of copper coiled wire when using them in a solenoid fashion. That being having a coil of copper wire with a metal rod running through the middle of it. So without further ado, we'll move on into the computer design. And here we have it. You can see the hand on the left from the previous design, of course, which fastens onto a ball joint to simulate the wrist. And then coming off that main ball joint shaft, we've got 4 brackets that are pivoting and they will hold the coils of copper wire. A problem I had fitting my own solenoids into the hand design in the previous video was that I was just using some regular plastic tubing to actually coil the wire around. And what I found when I was coiling the wire around was it was actually stretching the tubing and making the coils longer than I designed them to be. This was a problem because it meant I didn't get the amount of throw on the rod that passes through the middle as I needed. So to get around this issue, I'm going to be making my own fiberglass coil holders. These being these light coloured pieces that you can see on screen now. I'm making them out of fiberglass because that should be rigid enough, strong enough, should be pretty good with the heat that can be generated from these coils, while also not being conductive, so it's an insulating measure as well. And if we rotate around, you can see how all of these coils will fit together, and you can see a simple rod going through the bottom of it so you can understand how it connects to the hand part of the wrist. You might notice that this hand needs to move in multi-directions and I haven't got ball joints in every fitting, but I'm hoping with beveling out some of the holes and perhaps angling some of the shafts up that will connect the metal rods to the hand and everything, that I should be able to get full movement out of it without having to have ball joints everywhere. I would try to simulate those movements in Fusion 360 for you, but I am confident that my old laptop will definitely spontaneously combust if I tried to put it through that. And at the back you can see a design for a rotary actuator that will provide the rotation of the hand. This, however, won't be fitted in this video. Instead, I'm just going to fit this stand so it'll prop itself up for the video and for the testing. And lastly, we'll just take a look at the molds that I'm going to be 3D printing to make those fiberglass reels out of. Being a multi-piece split mold, they should come out pretty well, provided I can jam enough epoxy and enough strands of fiberglass into the mold. My only issue with that is that the walls are quite thin, being 2mm on the sleeve, so I will have to take my time on filling those molds. And you can just see to the right here what the reel should come out like and a cross section of it. With that all gone through, we'll separate these parts out and get them all printed out. I am, to be honest, wondering whether this coil and rod setup is going to be strong enough to lift the hand about effectively, but that is what these experiments are about, working out what works and what doesn't. First up, it's time to lay the fiberglass into those molds. I did make a slight blunder and I should have made these another split mold, so there'll be some cutting involved to split these molds and get the part out, but is what it is. And as normal, my chosen release agent is wax, applied with a toothbrush. Don't knock it till you've tried it, it gets in all the grooves, especially when it comes to 3D printing. I didn't have any fiberglass chopped mat, so I did have to make it myself. It took quite a while actually, but once that was done, mixed the epoxy and started pouring the epoxy in, and then just try to jam some of the fiberglass weave into it. I wasn't too bothered if it was epoxy heavy, as I'd rather have more epoxy to see how it behaves under the heat, whereas I'm pretty sure the fiberglass matting will be alright regardless, and the failure point with the heat in mind will be the epoxy. While that was setting, it was time to build up the rest of the 3D printed parts. That's the main pieces put together and mounted onto the stand. Got the holders for the coils and it all moves around pretty good. Moves around in all directions, and we do have a bit of movement side to side, which hopefully will be enough to get the angle correct for that. It was then time to demold and trim off those wire holders. I've now cleaned the little spools, the little wire holders up, and these have come out really well, surprisingly well. I thought these were going to be the disaster of the week, but they're actually come out really strong and really tough, smooth in general, apart from where I've screwed up and not put enough epoxy resin and fiberglass paste in the bottom of each one. But regardless of this flaw, which is just me being an absolute idiot and not putting enough in, they're really tough and actually really smooth, even on the ends with the flaw. They don't feel like they're going to break at all, which is very surprising and something I'm very pleased about. And they even slot in and fit in pretty nice, like that. So they are absolutely perfect. So we'll get some wire wound around them now and see how they perform. As for the copper wire itself, we've got 0.4mm thick, and then we've got 0.5mm and then 0.8mm. So we've got a decent range to try. That is measured in diameter as well, so you can imagine as an actual like a surface area, if you looked at the end of the coil, it is quite a big difference. We've got one already wound in 0.4mm. So we'll get the other 3 wound, and for the last one, I think I'm gonna go with a lot less turns just to see what happens. And I think I'll do that in 0.8.
I have got quite a bit better at winding these coils. However, counting them, not so much. I'm kind of just going until the coils are full at this point.
And here is 0.8.
However, I'm thinking about in the future making a bit of a frame with a stepper motor and an Arduino so I can set it to wind a certain amount of coils. But for this video, it's really about coiling as much wire as possible in the physical space allowed.
And now for the final one, I'm going to do a smaller amount of 0.8.
Something I have found is the thicker the wire, the harder it is to wind it on and get it really neat, as you can probably see here.
And now we'll cut the steel rods that go through the middle. Ideally, I'd use iron rods, but actually like pure iron rod is actually quite hard to find. Mild steel is obviously everywhere. And I intend on using SMC cores in the future, soft magnetic composites. So we'll stick with the steel bars for now.
The reason, if I remember rightly, that iron rods are used for this instead of steel is that pure iron has a lower magnetic reluctance, meaning it's less likely to become magnetized, and I think it just offers a better magnetic field for this as well. It will be interesting to see how a soft magnetic composite core compares to steel and compared to iron, something we'll find out in later videos.
We've now got the rods with the holes in them, and then what I've done is I've took a little M4 bolt, bent it up at the edge, which allows it to be a turning axle, if you will, which you'll get how that works in a second. So if we look at the 3D printed parts that we assembled earlier, you can see how I've got 3 of them in and how they move around. So we'll fit the last one now. That spool of wire is nicely pressed in. It's actually quite tight without glue. And then we've got the nuts on the ends of the bolts there to make sure it all doesn't fall out. Obviously, this is very loosely fit, and on future versions, it all needs to be a bit tighter, but it's good enough for this experiment. So you can see now how you have movement in all directions, despite the fact that you don't have ball joints on these pivots here. They're just on axles, with the bolts bent up at the end, so it all rotates around nicely and moves in all directions. There is a little bit of drag, don't get me wrong, but it's not bad in general. We've now got it all wired up to my little switch holder running off a DeWalt battery. So we'll see how it does.
Something I should have done is mark up which switch went to which coil, but I kind of didn't. But you can see it is at least initially working in various different directions.
Because I don't know what this battery is handing over in amperage, I'm going to change over to my little power supply. It'll only put out 5 amps, so we will know at least what it's putting through.
Something that it was at this point was very fast, as you can see, but I was getting the impression it wasn't that powerful. It did look to be dragging in certain directions, even though it all moved pretty well in my hand. But I thought I'd get the hand attached and see if it would actually move it. Best case is it'll lift it up for a small amount of time. Worst case, it won't do much of anything. And as you can see, it's trying, but there's just nowhere near enough power to lift that hand up.
So I've took all of the copper wires from the previous video out of the hand just to lighten it and see if it does anything here.
And again, it didn't do much then. However, it actually seemed to do worse, and this led me to think that I might have burnt some of the enameled coating off of some of the coils of copper wire. So I took my hand back off and then decided to spray them all in WD-40 to see what smoked and what didn't. And with the switches left on, you can see that smoke started to appear, but not from all of the coils. Something I did seem to notice is the 0.8 wire did seem to heat up and keep its heat for a lot longer. The best performing coil seemed to be the 0.5mm wire that also had a lot of turns on it. So I think in future I will probably stick to that thickness.
So, can a simple solenoid setup like this be suitable for a robotic forearm, particularly for the wrist movement? As you've probably guessed by now, no. There's just not enough strength, and even if you added some springs and stuff to centre it out, it's just going to heat up too much. But to be honest, this is all part of the early experiments of a project like this to me. And the parts that are a success of this little video is the fact that the actual frame and movement of the wrist is pretty good. Like, that's roughly what I want. The fact that it moves around in all directions and is pretty simple. This frame mechanism and everything should allow me to replace these and try a different sort, probably a form of stepper motor, I think, next. Something that was a success though was actually making these fiberglass spool holders. They've actually worked really well. I've heated these up now to the point where the enamel coating's melted and the fiberglass spool reel holders, whatever you want to call them, have survived pretty well, which has cured the issue that I was having with the hand in the previous video. I still think using these solenoid setups is pretty good for the fingers, just because you can have them really thin and long. And you also have this bounce in the solenoids when you're gripping something, so it's not just on off. You can actually grip it and it bounces without having to have complicated software that allows it. But I think the idea of using these solenoids for things is probably limited to that for a robot. So for the next video on the robot project, we'll either be redoing this wrist portion here or be moving on to another segment of the robot. However, the next video on the channel, providing it all goes to plan, will be some armor testing for the suit of power armor. So if you're new to the channel, please like, subscribe. I hope to see you in the next video, and last of all, have a great day.